Okay guys, today we are going to cover Newton's third law of motion. So at this point, on this paper we should have Newton's first law, the law of inertia, written down. We should also have Newton's second law, the law of force and acceleration, written down. And today we are going to work on Newton's third law. So go ahead and go to this foldable in your notebook and open up the Newton's third law tab. And for this law, we are going, it's actually, the title is the law of action-reaction. Let's zoom in. The law of action-reaction. So this law, almost barely didn't fit. This law is very straightforward and also very short. So this law states that for every action, there's an equal and opposite reaction. So let's get that written down. For every action, there is an equal and opposite reaction. I'm going to move this down so it doesn't get squished. So for every action, there is an equal and opposite reaction. For every action, there's an equal and opposite reaction. So now we're going to want to look at some examples. So you were given another paper that says Newton's third law examples. So what we are going to do is we are going to cut this out along the solid line on the outside. And for this one, I'm also actually going to cut out Newton's third law examples, this title, and keep it. If you think it's not, actually it is going to fit in your notebook because this right here is going to get folded up. So go ahead and keep the title also. So once you cut it out, it's going to look something like this. I am going to separate the title from the actual foldable. If you want to keep it attached, you are more than welcome to. I just want to be able to place these wherever I would like in my notebook. So before we actually fold it, I want to go ahead and write our notes on it so that it's easy for us to write everything and we're not trying to unfold it to write. So if you need to pause the video to go ahead and cut your stuff out and get to where I'm at, go ahead and do that now. Once you're ready, you are going to find your second law notes and go ahead and go to the next page in your notebook so that we are ready for the third law. So here's some examples that show the law of action-reaction. So we're going to explain in our own words these three different examples and how they apply to the law. So the first example that we have is explain in your own words how a rocket is able to lift off. So I want you to think about how a rocket lifts off. What do you see whenever there's a rocket launch? So just think about that for a second. And now we are going to put this into our own words to explain it. So let me get to my paper here so that we all write down the same thing. When a rocket ignites, the thrust from the engine goes down toward the earth. So that's whenever you see a rocket launch and you see all of those flames coming out of the bottom of the rocket, kind of what's shown right here. That's what we call thrust. So thrust is a force that's going to push down on the earth, but then the rocket is going to move up in the opposite direction. So that would be your action is the thrust leaving the rocket pushing down, and the reaction is that your rocket moves upward away from the force of the thrust. So let's go ahead and put that into our own words. So when a rocket ignites, the thrust from the engine goes toward the earth actually going to move my notebook. The spirals are making it a little hard to write on. So when a rocket ignites, the thrust from the engine goes toward the earth but the rocket moves up in the opposite direction. I did not leave very much space in between those two words, my bad. So when a rocket ignites, the thrust from the engine goes toward the Earth, so the thrust is going to go this way, but the rocket moves up in the opposite direction. So you see this is a pair of forces for our action and our reaction. Then our next example, if you move down, you can see a little skateboard in the background. That's what we're going to be working with. So explain in your own words what would happen if you were standing on a skateboard and then pushed the wall. So imagine that you are standing on a skateboard facing a wall, and you put your hands up on the wall and you push yourself off of the wall. So if I was standing on a skateboard, and pushed against the wall, I would move in the opposite direction from the wall, and in parentheses I'm going to put force. So here's what this is going to look like. You are going to push off the wall, but your body is going to move the opposite direction. So again, we have another pair of forces, our action and our reaction. We push against the wall, but we move in the opposite direction from our force. So if you need to pause right here to catch up on either of these notes, go ahead and do that. If not, we are going to move on to our third and final example for Newton's third law of motion. So down at the bottom, explain what would happen in your own words if you were to let an untied balloon go, and why would it act this way? So an untied balloon, what this means is not one that's filled with helium necessarily, but if you just have a balloon and you blow it up and you don't tie it off, and instead you're just pinching the end, and then you decide to let the balloon go. If we've ever done this, we know that it acts crazy and it starts flying all over the place, and that's because air is coming out of the opening of the balloon, pushing it in the opposite direction. So here's how we're going to write that down. When I let go of an untied balloon, that's how we're going to start. When I let go of an untied balloon, I'm going to actually add filled with air. The air would flow out of the balloon in one direction. So far we have written down, when I let go of an untied balloon filled with air, the air would flow out of the balloon in one direction, but the balloon would fly away in the opposite direction. But the balloon would fly away in the opposite direction. So again, we have an untied balloon, and we let go of that balloon. The air from the balloon is going to push one direction, and then the balloon is going to fly in the opposite direction. So you see, again, we have a pair of forces where we have an action and a reaction, and they are equal but opposite. So now we have our notes written down, and here is how we are going to fold this to get it into our notebook. We want to be able to read it and pull it down right here, this tab with the dotted line. This is the only place that we're going to add glue. So first, in between the first and second example along this shortened line, we're just going to fold right here on the line. We're going to fold this over, kind of try to align it. So right now we can't read anything. This doesn't do us any good. So what we're going to do is we're going to take this top part. So you see now we folded between the first and second. We want to fold the third example down along this line so that we can actually read what we wrote. Okay, so now it's going to look like this. We're going to be able to unfold it kind of like an accordion. So now that we have it folded, we have our notebook. The only place that we're going to put glue is right here, this top tab again that has the dotted line. We're going to add some glue to this line. Take your glue stick, just put some glue right here across the top. Make sure it's not on my notebook. And we can go ahead and glue it down just like this. So now we're going to be able to pull it out and read some of our examples. And then remember that I kept the title for this one. So I'm going to put some glue on the back of the title and get it glued down just like this. If you don't have enough room in your notebook to glue down the label, you could also cut off the word examples to where it would just say Newton's third law. That would still let you know what law and what examples it is that we're looking at. So now we have our notes for Newton's third law. So you've now learned all 3 laws of motion. So what I need you to do now is go ahead and make sure that your scissors are put away. Make sure that your glue, we've screwed it down, put the lid back on very tightly, put this back in your bucket, scissors back in your bucket, and any extra paper from our notes that we cut out, please make sure that ends up in the recycle bin, and come show me your notes so that you can work on your assignment.